Hi everyone, here's Simone. Welcome to this new touch design tutorial. Today we will actually continue the same topic that we were exploring last time, and this is about nearest point calculation and why you should know the distance between a point and another point. I pushed the example a little bit forward with a proper distance calculation and not like fake it. And instead of instances, I have a vertex shader. Okay. The cheap things that was in the last tutorial was actually the calculation that I did by making an identifier for the distance, and this identifier was actually based on the absolute. Okay, and the absolute work only if the point, the factor, is inside of the geometry. But what if the point is outside? Then you start to have wrong behavior because you're actually reflecting the same things that are happening. So yeah, then it's kind of wrong. Hopefully there's like a function in the GLSL, you just write distance. We will build it together. I just want to explain you the structure. This example is actually sampling the point that we are seeing here rendered via texture. Easy. Took me a bunch of years to understand all the structure, but actually it's pretty easy. Here is the render setup. I have a camera that is kind of rotating with the object, so you have, I don't know, movements to the scene. And this is the 3D view that show you the logic behind it. Okay. I can also, with the same technique, and this is was actually interested me, is that I can push the geometry. You see? I don't know if you can get it here, but here I'm like, oops, pushing the geometry due to the factor. And this is super cool because the form geometry is typically kind of heavy in the CPU. So I'm happy that they find a way to do it in the GPU. Now I need to make it usable. But anyway, the concept is clear, and this is what we learned today. Okay, so close this guy, make this main window, make a base, inside. Okay, data structure, 3D data structure in Touch Designer. If you have a sphere, uh, if you have a sphere, the sphere is a geometrical object that is represented in Touch Designer by a SOP. Okay, a SOP context. The SOP context has like point, vertex, and primitives. Okay, each of these, let's say, area of our 3D object can contain attributes. Okay, so attributes are like numbers that refer to a certain point, vertex, or primitive of our 3D object. Nice and clear. We will actually fake the point position by using the texture coordinate. So if you plan to use this with an 3D district that I will show you, this pipeline that we will discover with another 3D object, be aware that this has to have really, really, really good UV. With all that said, let's actually start. So we have this one, and the attribute, we can see it by opening this one or by converting this to dot, so SOP to dot. P and N, this stay for point position, this stay for normals. There's an array of 4, it's a vec4 for position and a vec3 for normals. Yeah, that's it for now, so thanks. You will need the component I I made that I show a bunch of time where to get it, it's an unwrapper. So you need to unwrap the texture coordinate. A link will be in the video description where to get it. Utility unwrapper. Check my other tutorial, I tell a bunch of time where to get this. It's kind of fundamental for my workflow. Okay, so now we have a texture that is representing the point. We see that the texture is broken, and is broken also in the kind of word. Okay, here is broken. Last time we fixed it with the texture swap. Actually, it's wrong. You can do it here and say by primitive type, and this get fixed automatically. And also the disposition of the point. I like it better, it's organized. Really nice. So this unwrapper, what it does? It gives us point position and actually give us vertex position and vertex normals. Because this is what the phone is reading. Okay, so phone render buffer, make buffer here, here, and render select the position and the normals. Nice. Okay. And actually the normals are equal to the position, because if you visualize the normal here, they're the same. Voila. This is why the textures are the same. Same point, same normal. Okay. So yeah, actually we can use only this one, but if you then pipe another object, these two will be different. So let's keep it divided for now. Okay, so we have the starting point. Then we want a point, so an object that can affect our point. So we can do it with a constant, and just for sanity, because actually it can be another object, another point cloud actually, because we're working with point cloud here. So it's a point cloud to actual 3D geometry. Let's say this is our affector. Okay, affector. Hope I type it correctly. And so just to keep everything procedural, because this is 32, this is not 32, and it's not the resolution we want, we connect it. We go to the output of our affector and please set resolution only. Nice. Okay. Then we have to compile a simple GLSL and invoke a function that will allow us to have the Euclidean distance between two vectors. I'm not on a Mac. Let's do the things super optimized. This will be a mono, 32 mono. Okay. And so then I can just use the first part of the vector, so compile it is happy. And let's see. So we plug as the first input, we got the affector. So inside here, I want to call a vec4 that is I call it AF, and is sampling the first texture. Then I want also to sample the second texture, and this is our position. And I'm sampling this texture from the input. Then we have to define a function for the color, okay? That in my case can be a float, because I squeeze this from this, okay? So I can say that this is a float, and I want to calculate the distance How cool is that? You just type distance. Between what? Within our position and our effector. And we have an error. I may distance browser flag color and out for what I mistype. Okay. Distance, pardon. Of course, you have to type it correctly. Distance. Okay. And we have the distance. So we can change the name of this guy to distance. Okay, you can also start to figure it out how to type here if else and make a threshold in here. I kindly suggest you to make a threshold top. Fair enough. Okay, so now we have the mask. Okay, that is like telling me where I have the distance that I want. So in all the others this. You can say greater or equal, and I have only this part. Now, so this is the mask. This is this mask. Okay, and usually what to do with a mask, you multiply it for something. And let's say that I want the prefix layer here set it to 1 because this is a monochrome things, but I want to keep the color format 32-bit float RGBA. This is sadly a mono, but it's just for performance, and it's anyway super fast, just to show you. And then I want to keep the data, data format 32-bit RGBA, and do not care about this, so the fixed layer should be moved to 1. Super important. Or you can just put this one above, but it's just to explain you how to. Okay, so now I have this, not the effector, but the position. Pardon. Okay, now we have some values. This part of the sphere. Nice. Okay, and let's do the same for the normal. So null. We say this is new and new pos and pos. And then we take the normal as well, so we copy this guy and we substitute this cable here with this cable here. Actually, not in both, but just in this one. Here we go. Okay, and this is new normals. Okay, now we plug we drop a fong and we try to output the shader. The shader is compiled, so can be outputted, and I want to include a geometry, maybe for later, and I don't know if this is make any difference, but I'm not thinking the fong. Now we have the same code that is compiling this shader, okay, in code, and it's the simplest fong you can have because I didn't put anything inside, right? Anything. So maybe we can make, just for example, a noise, and at least let's give him a color. So this is color. Since I have an exact copy of it, this is new pos that I don't care, and yeah. So now I have a font that have at least a color, and I want the code for it. Yeah, this is the error I was trying to show you. So if you want to compile a shader properly, not taking the default one that is precompiled when you drop this guy, now I make some changes and touch designer say, hey, this is like only in your mind. For me, it doesn't exist. This is what is written here, kind of. So, okay, how can you make touch designer understand and compile the shader that want to be outputted? Actually, this is from Vulkan, because before it was outputted anyway. you put it here, and then this guy is happy, and you can output a shader. Because you need a render as well. Of course, the pipeline must be completed. Okay, so yeah, even if it's little black, that's nothing. Let's put I have a torus, pretty nice torus with a texture. So yeah, I see it. Can you give me the code now? Ta-da! So now I can have the code with the texture. So I can apply this, delete this, and I'm happy. Okay. Today we will actually work only with the vertex shader. So I can put those away. I want to use only this one. And since the pipeline will require other data like the texture that we have here, but we do not have it here. We need anyway to plug this SOP in the geometry. Okay, so we can delete the geometry, make a null SOP, and call this beautiful null SOP to geo. And then from here we can make a geometry that now she's rendered and can take the shader we want to apply. Pretty nice. Now we have a shaded sphere with a foam material that we can manipulate. Something like that. I don't know. Bluish. Okay. We have light, we have diffuse, specular, blah blah blah. Really nice. Okay, so what we need to do, we need also to configure some sampler because we will sample things. Okay, so let's just be super good and use the last version. Doesn't really matter. I see some millisecond difference, so I want to use it. The sampler is already set it up for us, okay, and give us some idea how is the structure. So we have to define a top, and the name must be with an S. Okay. Theoretically, in top must be with an S. So if you use, yeah, this has to be with an S. This can also be with another name, but let's keep the things as they are, and this has to be with a name. So you call it in the shader, and the name you want to have is this one, but this S has to be actually not in the sample, but in here must be, and here not. But we keep it with an S, since Touch Designer give us this. Okay, so new sampler. What we want to sample? The position. How we want to call it? S pose. Nice. Then another sampler. What we want to sample? The normals, and we call it as norm. Okay. And I guess this S allows us also to use textile fetch. I'm not sure. Anyway, let's open our text editor. Please go back to the network and take a vertex shader. Open it. All right. Okay. So this is where we can do things kind of easily. Okay, in the geometry it's a bit more tricky. Here it's kind of easy to work with points. And so you got the idea. What are those? Those are values that can change every frame, so you can interact with the shader, and they're called uniform. In our case, we need a special type of uniform. Special type. That in our case it's a type of a uniform. That is called a sampler 2D. Okay, and we have to give the name of the sampler we are looking for, and the sampler name must be the same of this. So I just take it and put it here. You need to always close the semicolon. Then same stuff for the norm. Nice. Okay, so here what we did, I did my uniform. Okay, this is a data structure that Touch Designer is using inside of the GLSL material to use the OpenGL render pipeline. Okay, this is a structure that in our case contain a color, workspace position, normal. These are super important for us, and for different reason, and this that I will not use it. Okay, so this is what happened before. It's like a preparation. Okay, what is actually cooking every frame is what is written here, from line 26 until line 65. Okay, so those stuff are going every frame. Okay, and because these are uniform and not custom value, they can change as well every frame. Okay. All right. So here we have to make some little changes because we want to sample something that is a texture, and we need some coordinate that makes sense for the object, for a 3D object. Okay, we have it already, but not in the right order because we want to deform position. But in order to do that, I want to sample something that is my new position, but I need some coordinates. So we make like that. Okay. So then we have this unwrap coordinate that I can use. Nice. Let's now define in the void, we take this. Okay, so we want to use a sampler in the void. How to do it? You need to use, you can use some function that can sample things like texel fetch or texture. In this case doesn't really matter. The most precise is texel fetch. Today we will use texture. So I want to sample a vec4 because this is RGBA and it's not written here, so I need to tell it here. I want to define a vec4 that is my new position. Pretty nice. Okay, so now this new position, okay, what we want to do with this new position? Let's say we use the texture function that is a sampler that sample texture. So use texture. Okay, and what we want to sample? We want to sample as pose. Okay, how I exchange the position of this one before this one. So now here in between, this is where you can do all the transformation before the data are actually passed to the GLSL render, okay, the GL position here. And when it's there, it's there. So you can do nothing more, but you can manipulate here. So I'm taking the texture, okay, and I want to sample the texture with the coordinate of the object. So this is coming from the top, and I'm using a data that is actually coming from our geocomp. This one, dot xy, because this is a 2D sampler. So it's a flat texture, so we just need a UV, kind of UV according to our 3D object, that is this one. Okay, we write it really slow, so let's copy it and use it also for S norm. I can just call it norm and sample S norm. Nice. Then I can like put the new position I got inside of the TD deform. What is happening here is like creating a variable that is calling a function. This is a predefined GLSL material function that is returning my position in the word space. So that makes sense for a render. If I didn't make any mistake, voila, you see, we are actually having this. That is not making a lot of sense to you, but let's add a box. And yes, it will be a bit tricky. So we need to create a geometry with the box, and it's there. But to make it a little bit smaller, and give it a red color, just to show. Okay, red, please. Okay. Where do we want to have this object? Okay, we want to move this object and move it accordingly to our effector. So we can take the position from the effector. Okay, here or there doesn't matter because it will bind it. So bind. Okay, and as you can see, this goes in this position. Pretty nice. Let's move the camera a bit forward, and let's also display the wall geometry, so we can make another from this null. We open another geometry. No. Here, there, and let's give just a simple wireframe. And voila. Okay. So if I then now move my effector, you see, I'm actually displaying only the vertices of the sphere that are in the area of the effector. Okay. And because we are actually seeing now in the XZ plane how to have a box that is rotating around the sphere in the XZ plane, you can do it with Python math.sine here, because sine and cosine make a sphere, so you can just call something that moves inside a sine function, and you have stand 6 seconds, and you have these things. Then you can say the same things for the z-axis, that in this case is a color, but for me represent a vector, so b is w. You can then set it to be a cosine, and this guy is rotating around the sphere, but it's like attached to the sphere. Okay, let's say we want to have it a bit more you want to set a distance from this effector. Okay, so you can do it, of course. It's a bit tricky to understand, but I show you how. I hope. Where is the guy that is the funk? Is this box? Should I like name things better? I'm pretty disorganized, but doesn't matter. So here we have those coordinates that are rotating around the sphere. Hopefully we can set some coordinate before. Nice. So let's say I want to take this coordinate here again and put it in the preform and reference it. Then you can see I'm like in the, let's say, double of the distance, and it's detached, but it's anyway rotating around this. So by scaling by scaling those pre-transformation, because here I have a transformation that is always rotating, so I need to use those that are also rotating, but because it's pre, I'm like moving it away, and then it's like double rotating, so it's making a distance by maintaining the rotation. If you add here, I don't know, take a constant, right, and you set it, for, I don't know, display dist audible. Let's just call it A because I need to write it. So here, okay, so I can say times what, and a scale value that is in my case the operator A, and I want the first channel of this job. You can then multiply this by everything, and this goes attached to the sphere. And then voila, it's rotating, but you can choose the distance. Okay, let's say you don't want to have this horrible like no, yeah, so these kind of feelings that are like super geometrical, so you want to have a smooth surface, you can do it really easily by going in the threshold and tell it to be not so hard. And then this is what happened. This one. Okay. Then let's actually finish it in the proper way. I don't know if if it makes any difference, because I cannot see any difference, but you can also pass because we actually sample it here. Where is it? Because we have it here, so let's just use it in the shader and take out some CPU usage, okay, from the geo, because we want to be super optimized. So let's just use norm here dot x, y, z. So nothing changed, okay, but actually from this geometry here, that is actually our geometry that is taking this material that has the trick inside, okay, it's passing some value. Less value pass, first more you sample, faster you can go with a huge amount of points. This is also really important to take in consideration. Okay, hope you will like this tutorial. Hope you get the point how powerful it is just to have value in texture and sample it in a shader. And I will continue to this kind of tutorial, because it's like hidden gem that you have to understand in order to make real-time stuff. Wishing you all the best. I say hello.